What is up, everybody? It's Alex Louis here in my YouTube channel, brought to you by Vexta. So I want to thank you for joining this channel, subscribing, and I'm gonna get right into it. A lot of new exciting things are going on in this channel, and I'm even gonna put in a new mini course for everybody to enjoy, and it's all gonna be free. So one of the new things that I'm going to start out is I'm going to start out putting out solutions on algorithmic problems. So I did get a question from a user, which I am going to put up a solution right now. That's what we're going to talk about here. And if you do have further algorithmic problems, I can break it down for you and teach you strategies on how to attack them. So let's take a look at this problem, which was sent to me by a user. So this section of my channel is going to be called Attacking Algorithm Problems. So let's take a look at this right now. So the problem actually is a lot longer than this, and I kind of dissected text from it so that we are able to focus on different parts of the problem. At the end of the video, I'm going to show you the actual text, excuse me, which you're gonna see that it is pretty long and long-winded and extensive. But what I generally tend to try to do is when I was faced with these problems in the past, I like dissecting it and taking it apart piece by piece. Obviously, if you're in an interview, this isn't going to be the case because you really only have an hour and a half. But it does train your mind to think in a way that you go piece by piece by piece and you extract things out. So I'm going to take a minute and read this. Basically, the problem says that you work for a video company and you have to come up with a way to take these automated shots of a film and just give back a number of inputs of shots for the film in a sequential manner. The algorithm right now labels each shot by a letter, and then any identical scene will be labeled with the same letter. So if you have a movie scene, let's just say A, and then somewhere along the sequence the same movie scene appears, you want to say that once you reach the end of the duplication, that is the end of your kind of groupings of scenes. So let's take a closer look at that. It's easier for me to show you visually. So here's my visual example, right? So this is just pictures that I took out from when I went to Hawaii a couple years ago. And you can think of it that way. So there's a sequence of shots, right? And if you see, there's a couple of shots that have been duplicated. So you see that the second shot is duplicated somewhere along the line. The first shot is also duplicated somewhere along the line, right? So, and then remember that we did say that an algorithm currently exists that breaks the film up in shots and labels them with a letter, and identical shots are labeled with the same letter. So it helps to visualize this and actually draw little pictures, because if I was just going to give you this text to solve, it'd almost be it'd probably take you like about, and it took me, maybe you're a genius, but I'm not. It took me about a good 30 minutes to just kind of understand what the hell they were asking, okay? So you have this, now you know that this is an array. So in this array, you're going to have the sequence of shots, right? And somewhere along the line, the repeats are going to stop. Okay, so that segues me into the second part. So we look at this let's say this is scene A as B, because obviously they're different, right? But then we go again into scene A because that's the same shot as the previous. I know it is the same shot. It's just a little enlarged, so don't mind that. So then we have A, B, and then B again, because if you see that, that's the same shot as B. Now C, the next shot is different because it's not any of the ones before. Then you have B again, then you'll have A, then C again, then A again, And now is an interesting part in this kind of sequence is that me on the elevator is actually no repeat from before, so that's going to be D, right? So that's a new shot. And then, and sorry, I couldn't put this whole thing on one straight line, so just think of this as a continuation. Then you have E, which is the next movie shot, then F, then E again because it repeats. Then that's a whole new shot, which is G. Then it repeats again, right, from the elevator shot, which goes back to D, okay, and then again repeat, and then a whole new shot. So again, the whole problem, I'm going to show you the whole problem of what the big sequence is. I just extracted a little bit of the sequence of the problem so that you can see kind of visually how it works, but there's more sequence letters or sequence shots that are missing. So, and we'll look at that in algorithmic manner, but I hope you understand now what we're trying to see. So we have our shots, right? Don't mind too much of the pictures. I mean, the pictures is just a good thing so you see what's happening, but each shot is labeled as a letter in our array. So basically our sequence is going to be, the letter would be the contents of the array, and then and the index would be as to where I'm currently at. So and that's a given, right? So A, B, C, B, A, C, A, then D, E, F, E, G, D, H. Okay. Now, our conditions are that we have these shots that are labeled by a letter. The identical ones are going to be the same letter, so we know where each individual letter repeats, right? Each shot repeats. Here's where the problem gets interesting. So now this is kind of what you have to accomplish, okay? So we want to write a function to split the film into as many short scenes as possible without confusing the viewers, by having the same shot appear in different scenes. So that is something that, again, you got to kind of do a double take on this. So your function is going to partition the sequence of shot labels into scenes so that no shot label appears in more than one scene and each scene is as short as possible. And what I said was the output is going to be the length of each scene. Okay, that's a lot to take in. That's a lot to take in. Again, I like to draw pictures in this so that people understand what is actually happening. So first we extracted the part of where we're trying to just understand what we have as input, right? And now we're trying to go into the process part in trying to understand what's actually happening here in terms of what are they asking. So one is you're going to be asked to write a function, okay, and I can kind of break this down to you. So what they want, okay, is they want you to segregate the scenes so that if you have a scene that is duplicate, right, that stays in the first kind of segment of the scene. So basically you want to segment this array and then count how many shots are in this segment so that there is no duplication. So let's take a look visually, okay? So if we go back to our visual example, you see that the A is going to repeat somewhere down the line, right? So if we go all the way here, it repeats over here. So if we segment the array, okay, we know that we cannot have a segment that has A as part of its group, right? Because you don't want A to be in segment 1 and A to be in segment 2. Same thing with B, right? Because B should still be in segment 1. It should not be in segment 2 because it repeats, right? You don't want it to repeat. So if you segment the array somewhere down here, okay, that's no good because you still have B repeating. So that's why it says, if we go back, let's go back. It says you don't want to confuse the viewers by having the same shot appear in different scenes. So this shot appeared in this scene, right? And if I stop the scene somewhere over here, you're going to confuse the viewers because B appears again. So if you want to segment this in an efficient manner, as they're asking you to do, you probably would have to segment it somewhere before D, right? Because before D, this will be your first segment over here. None of these are going to repeat again. Okay, so this would be my first segment, and then we start a second segment at D. Now, let's look at this more visual. So if we're kind of starting to cook up a solution, right, in terms of our array and our problem and our function, we are looking at traversing the array one by one, right? And we're always chasing as to where the duplicate lies, right? So that in itself tells you that we're going to have to do something where we have to loop twice. One is to find where this lastly duplicates, right? Because if I can find where this one duplicates last, then I know that I have to stop at that point. Now, I didn't take into account that perhaps this one can duplicate B, which is B. This one can duplicate also. So I kind of have to expand my line of duplication. We can call this like my wall, where B, if the duplication of B happens after A, then that kind of has to be my new barrier of where I have to reach, right? Then A comes again, and we're okay with that. B comes again because we know that we know already where the farthest duplication is. And then C, we don't know where the farthest duplication. I mean, we can see it right now, but we're gonna have to find that out, okay? So we don't know where the farthest duplication of C is, right? So we have to take into account that in our heads that okay, if the farthest duplication of C is greater than the farthest duplication of B, right, or the one before it, then that's my new kind of cutoff point where I have to leave, right? So if I look at this closely, right, we can see that this is going to be my first segment. Why? Okay, so let's kind of traverse this one by one, right? So A, what's my farthest duplication? My farthest duplication is over here, right? So I'm going to place kind of a line here as, okay, this is where I'm going to stop my segment, because that is my farthest duplication. In this, if we segment here, then we're guaranteed that no duplicate scene will happen again after this, right? Now bear with me, okay? I'm giving you kind of like the logical reasoning. We're gonna have to find this out. Like you're probably asking, well, how am I gonna find the highest duplication? Bear with me, okay? We're doing this piece by piece. So if A's highest duplication is somewhere over here, okay, we still have to look everything in front of us. So let's go to the next one. So B, who's the highest where's the highest duplication? Well, the highest duplication is over here, okay? And remember, we have to compare, right? Is the highest duplication of B greater than the highest duplication of A? No, it's not. So we are safe to keep segmenting here, okay? So we safely can say that, okay, so the highest duplication is still A, so we're good. A comes in, we ignore it because we already know the highest duplication, right? So, and then B, we know the highest duplication is going to be over here, and we know that the highest duplication of B is still not greater than A, right? Well, we don't see that. And then C, now we have a new scene, right? What is the highest duplication of C? Well, the highest duplication of C is right before A, but it's not quite A, which means that we're not going to replace it. We can still segment here safely, right? Then we have B again, then we have A, then we have C again. C again, highest duplication is still over here. then we have A, and then we have D, right? Okay, so D is now not my highest duplication, but it's a new a letter. Okay, so at this point we can actually stop, and now we've created our first segment, because at the point that we have D, okay, we know that everything before that has already been duplicated. Because remember, we already found the highest duplication for A. If B had a higher duplication than A, right, somewhere over here, then D would have to been pushed forward. So we would never have reached D at that point. But we know that the highest duplication, we know that at this point, that's it. So, and then when we reach this segment, okay, or this element, then we segment this and we count the number of shots. So the number of shots here are 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the first segment is going to be 9 shots. Then our next segment is going to be, again, we start again, right? So what's the highest duplication of D? The highest duplication of D is somewhere over here, right? We go to the next letter. What's the highest duplication of E? Well, the highest duplication of E is 1 after E. So that is kind of our new high, right? It replaces now. So we're moving forward now, right? We're extending that kind of segment line. So in this case, right? In this case, we can say we move the goalpost. So now our highest duplication point is up to here because we got to E. Then we go to F. What's the highest duplication of F? Well, we don't know, right? I'm sorry, we know. There's only one, so that doesn't beat out E, right? Then E, we know that's up here. G, we know that there is no higher duplication. And then D, what's the highest duplication? It's still this element, so that doesn't change. And then E. So we reach the highest duplication of the next segment, okay? And we can safely say that we can stop over here because the next letter is H. And that, at this point, okay, there is no, all the ones before E, have been duplicated and done with, okay? So we label this as the second segment. How many shots are there in this second segment? And what we count, so it's now 10, I'm sorry, 1, 2, 3, 4, 5, 6, 7. So if we take a look, we can say that scene 1 is going to have the 9 shots. Scene 2 is going to have the 7 shots. Okay, and then we're missing scene 3, but we'll take a look at that in a closer look in the next slide. Okay, so that's kind of how our algorithm's going to work. We need to find the highest duplication. So start thinking about this, right? So the first step, remember, we need to find the highest duplication. So should we go through and traverse the array and count how many A's there are and where the highest duplication lies? So there's a lot of things that can go wrong with trying to solve this simultaneously, because probably what you want to do is do everything at once. It's okay. It's okay to go with that approach. You kind of have to go with the most naive approach. But I'm going to try to show you the most efficient approach, because for this problem you're going to have to loop twice. One is to find the highest duplication, right, of each letter, right, and then the next time is, and as you saw, right, so when I was traversing and segmenting the array, I already knew where the highest duplication was, and it kind of came out. You probably thought, well, how does he know, right? Well, we know because we're going to loop through the array, and we're going to find the highest duplications of each. So that's going to be our first task. Once we know where the highest duplications are for each letter, then we'll be able to segment the array and count the number of shots. Okay. So here's kind of like the first crack at. So this is the actual input. Okay. So in this particular case, you have A, B, A, B, C, B, A, C, A. Okay, and my first segment is going to occur somewhere over here. Then we have D, E, F, E, F, E, G, D, E, H. Second segment is going to occur somewhere on the 15th element, and then the third segment will occur, we'll start at 16, and then we count 1, 2, 3, 4, 5, 6, 7, the eighth element. Okay, I'm sorry, eight shots for the third segment, right? So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So 8 shots for the third scene, and then we'll solve for this one, and then we'll go through smaller examples in the next couple of videos. Okay. So I hope you understood what the task at hand is. On the next video, what I'm going to do is I am going to show you the code and how we can break this up together. But maybe you want to give it a try, right? Maybe you want to give it a try before looking at the solution. But so think two things. One, I have to be able to partition or grab all the unique letters in my array and find where the highest duplication occurs, right? That's the first thing. So if I'm traversing through my array, I know that A, the highest duplication occurs in element 8, right? I know for B, the highest duplication occurs in element 5. And for C, I know the highest duplication occurs in element 7, right? Then you know for A, B, C, and then D, the highest duplication occurs in element 14. E, the highest duplication occurs in element 15, and so on, right? And then if we were looking at H, right, where's the highest duplication? The highest duplication is still 16, right? So we can stick to this scene, right? We got to look at the next one. Where's the highest duplication? Well, the highest duplication is 17. We're still in part of this scene. We can add it to our scene of shots, right? Because there's no duplicates yet. Then J, where's the highest duplication? The highest duplication is 23. Okay, so that means that we got to reach up to 23 to package all the next ones in my next scene, right? So, and as you'll see as we go through, none of these letters will be higher duplicates than J. So my third scene, the size is going to be 1, 2, 3, 4, 5, 6, 7, 8, right? 8. So hopefully you'll stay tuned in my next video. Now, on these videos, I'm going to use C#, okay? I'm going to use C#. It's because I am a Microsoft guy, so I'm a Microsoft JavaScript Angular person, .NET. So you could probably use the same example in Python or Java or C++. But we're definitely going to be using some data structures, and obviously we're going to be using some loops. So I hope to see you on the next video, and hopefully this has enhanced your understanding of this video problem. So I'll see you on the next video.